In our next station here, we're going to learn about the water quality. This is Mr. George Tinker. Come on around, gang, so that you can see. Stand right up here so that you can see what's going on.
Water quality is important in the estuary because many of the things that are harvested out of the estuary then become part of the food at your table. Oysters are one of those things. To sample water quality, let's look at some of the science behind this. Here we take a water sample that would be taken out of the estuary in a sterile bottle like this, and the water sample would come to us, and we would filter that water with a vacuum pump into a unit that would look like this with a very fine filter. This filter would be taken out and we would grow the bacteria for 24 hours, and after that it would look like this. And from this sample what we can see is on this side these here have a few bacteria colonies growing, and they represent a group of bacteria called fecal coliform. Those are from fecal sources. And when we have fecal sources present, we probably don't want to eat those things. If it's a small number like this, that's considered acceptable. If there are 14 or less fecal coliform per 100 milliliters of water, that passes the standard for sale. If we look at these samples over here, we can see that they have more than 14, and this has quite a large number. Water and animals harvested there, oysters, would not be for sale with that kind of number. Water would pass through the estuary and flush it out, and at a later time they would be back to this number and harvestable.
Now, Mr. Tinker, I have to just jump in here. We have a question from Grimsley High in Griffith County, North Carolina. Rachel, Ross, and Todd would like to know what types of pollution problems exist in the estuary, and would this be considered pollution?
It would be considered a source of pollution, and we have to identify that this is non-point source pollution is the term. We don't know exactly where it comes from. That's to be compared with pollution that might come out of a pipe where you know where it comes from. So the non-point sources are a little harder to track. We keep track of the bacteria counts here and determine whether it's harvestable season or not. And by and large, we have good quality water here, and it's only when we have a large rainfall that we get conditions that would represent this. Let's look at some of the other characteristics of the water that we sample. Over here.
This is a YSI meter, and it measures salinity and the temperature of the water. Right now, the salinity of this water is 15.3 parts per thousand, and the temperature is 21.3 degrees Celsius.
Also, another way to measure salinity is with a hand refractometer. A hand refractometer works by taking a water sample, placing it here, and what happens is light refracts and it is converted into a salinity reading, which is 14.
Okay, can we share that with our students here a little bit? Is that all right if you hold that so that they can look through?
Okay, we can pass that around.
We can't share that for our viewers
at home. Let's look at another characteristic of water here that we sample.
This is a pH meter. The pH meter measures basic acid, and life lives around pH 7, which is neutral. Estuaries tend to be above pH 7. Today's reading is 7.2.
Another characteristic of the water that we measure is turbidity. It would be measured by lowering a Secchi disc into the water, and we record the depth at which this disc disappears. And that would be a measurement of visibility in the water. Let's look at some of the data that we've collected. In collecting and doing this kind of an experiment, and monitoring is the appropriate term, we're keeping track of it on a daily or weekly or monthly basis. We have a set of what's called protocols. These are procedural steps that are written here. We follow these steps, we collect the information, and then we assemble it. And it would be reported back in forms that would look like this, perhaps a graph form. The important part about science is that you follow the experiment in a procedure and a very repeatable method. The last step that's important is that you take this information and you communicate it to others that need to know this information. This graph shows the relationship between fecal coliform bacteria and rainfall. Okay.
All right, hey, we've got a question here, George. Let's see what we got.
What are those?
This is another method that we can test for bacteria. This is what your city water would be tested. This would be using this method. This is called an IDEX test. And we see most of the cells look clear, but we see a couple here that have turned color. That means there are a few bacteria there.
Now, which city's water is that, George?
Okay, this could be from, this is not from a city water, because a city water would have a 0 content.
Ah, good.
This is from the bay called Sunset Bay nearby South Slough. So we see that's pretty clean water for ocean water, just very minimal numbers. If it was your city water in Coos Bay, they test this 15 times a week, and they should come out clear. If they're not clear, they add more chlorine.
So that should make us feel at least safe that they're killing the bacteria off, right?
This is a standard method of testing for bacteria in drinking water, estuaries water. The concern is for oysters, because oysters are filtering water, and if they are living in the estuary and they're filtering this bacteria, they can concentrate the bacteria. And the key thing is, you want to know what is the bacteria count, and if it's present, you want to be sure that it's under the limits allowed by law.
Now, I understand some oysters that are grown in South Slough, it's used as an area to purify oysters. Is that right? Because we have pretty good water
South Slough
quality?
has very high quality water, and so sometimes oysters grown in other areas are brought to South Slough, and if they sit there for several weeks of clearing themselves out, the bacteria count is reduced and they are harvestable for sale.